In this video, I will show you how to solve Blackjack in the Exercism Python track. So let's first remove these doc strings. Task 1. Calculate the value of a card. In Blackjack, it is up to each individual player if an ace is worth 1 or 11. Face cards J, Q, K are scored at 10 points and any other card is worth its pip value. Face cards Q, K are 10. Other cards are pip value. Define the value of card function. The function should return the numeric value. Numeric call value. If the passing card string of the passing card string. Since an ace can take on multiple values, 1 or 11, this function should fix the value of an ace card at 1 for the time being. Ace card is 1. For the time being. Later on, you will implement a function to determine the value of an ace card given an existing hand. So let's see. Let's enter. Let's try and write some code for this first. Face cards J, Q, K are 10. So if card is in, and then we'll create a tuple. We'll enter J, Q. We'll make it a string. J, Q, K. Numerical value. Let's just create a variable called numerical value, and then we'll assign 10 to it. So this is going to check if the number entered here in card, or if the card entered, the string is in J, Q, or K. So we're covering the face cards with this if statement. Then we're going to create another if statement, if card is equal to, so let's do this one, the ace card. If card is equal to A. Oh wait, we need to make this, of course, an elif statement. So it's going to check this first. It's going to check this first. Then if this is false, it's going to move on to else if. It's going to check this one. If elif card is A, then the numerical value is 1. And now we need to create an else statement. Other cards are pip values. So if it's not J, Q, or K, and it's not A, then it's gonna be a numerical card from 1 to 10. So we can just write an else statement, and then we can add the numerical value. We can add, sorry, else, yeah, numerical value. Now a card, else, yeah, numerical value, I think, is, then we just need to convert the string to an integer, so we can do int and then card. So the numerical value will be if then either number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is entered into card, then it will turn it into an integer number, and all we need to do now is to return the variable numerical value. So we return numerical, return numerical value. Okay, let's see. Let's run the test and see if this covers the exercise. Yep. Okay, so that's task 1. Task 2. Higher, determine higher value. Define the higher card function having parameters card 1 and card 2. For scoring purposes, the value of j, q, or k is 10. The value of j, q, or k is 10. The function should return which card has the higher value for scoring. Return which card has higher value. If both cards have equal value, cards have equal value, return both. Okay, so let's just remove this pre-written stuff. So we need to know the numerical value again, but we've already written this function which we can use. Yeah, we can call upon that, so we can create a variable called higher num card 1, for example, is equal to value of card and then card 1. Then we create another variable, higher num card 2, and then we'll call this value of card 2. Now we can use this in our if statement. If higher num card 1 is higher than higher num card 2, if it is bigger than higher num card 2, then we want to return So we need to return a higher card. So if higher num card 1, we want to return card 1. Yeah, we want to return card 1. Elif higher num card, if card 2 is bigger than card 1. So card 2 is bigger than card 1, then we want to return card 2 as the higher card. And then if they are equal, if this is not the case, then these values are equal. Then we need to return both cards, so card 1 comma card 2. Okay, let's run some tests, see if this covers task 2. Yep. Okay, so that was task 2. Let's move on to task 3. Calculate the value of an ace. Task 3. Calculate ace value. As mentioned before, an ace can be worth 1 or 11. Can be 1 or 11. Players try to get as close as possible to a score of 21. As close as possible to 21. Without going over 21. Then what else do we have? Define the value of cards function with the parameters card 1, card 2, which are a pair of cards already in the hand before getting an ace card. Your function will have to decide if the upcoming card will get a value of 1 or 11. And return that value. So return 1 or 11. So we return a value. The value of the hand with the ace card needs to be as high as possible without going over 21. If we already have an ace card, then the value of the upcoming ace would be 1. If already have ace, then we need to then ace value is 1. Okay, so this is all the info that we have, that we need, I guess, to complete task 3. So we need to call upon the value of card function again, because we need to know the value of the cards. So I will just replace the word higher with ace for this one, this variable, so that it's a unique variable. Because I think that's a good idea. I don't know. I don't know if that's, I haven't really learned much about variables yet, so, but I think that's a good practice maybe. And so what we'll do now is write an if statement again. If ace num card 1 plus ace num card 2, then I think we need to add, like, maybe we need to add some brackets. If ace num card 1 plus ace num card 2 plus 11 is smaller than or equal to 21, Then, so if this is the case, then we want to return 11 elif. I'll just copy this. We will just copy this. If it's bigger than 21, then we want to return 1 because we would go bust. This is return 1 or 11. This is something we've done. If you already have an ace, then the value is 1. So I'm not sure. Maybe we need to add like LF. If card 1 is equal to A, or card 2 is equal to A, if card 1 or A is equal to A, then maybe we need to write this as the first statement. We need to write this maybe as the first statement. If card 1 is A, it's equal to A, or card 2 is equal to A, then we need to return a value of 1, right? Yeah. Then we'll make this an LF statement. So first it's going to check, is there an A? If there's an A, it's going to return 1. Then it's going to check if the value of the first card and the value of the 2 card plus 11 is equal to or smaller than 21, then we can assign a value of 11. And in all other cases, basically, so we can rewrite this to else. In all other cases, we can basically return 1, I guess. I think that is the case. That is the case, I think. Let's see. We don't really need to have this, but let's just run the test and see if we have completed task 3. Yeah. Cool. Let's move to task 4. Task 4. Natural or blackjack hand. Natural or blackjack. If a player is dealt an ace, if ace and a 10 card plus 10 card, then the player has a score of 21, and that is called blackjack. Blackjack. Define the is blackjack function. Determine if the 2 card hand is a blackjack. And then return boolean, true or false. The score calculation can be done in many ways, but if possible, we'd like you to check if there is an ace and the 10 card in the hand, or at a certain position, as opposed to summing the hand values. Okay. If ace plus 10 card, then blackjack. So if card 1 is equal to A, and card 2 in 10 card. You can try this, but then we need to define. We need to define a variable called 10 card, and 10 card is a tuple, maybe, in a tuple is a 10 or a K or a K or a queen or a jack. Maybe we need to use 10 card in. No, 10 card is. Ten card is 10K queen jack. So it's going to check if card 1 is equal to A. So there's an so it's going to check if the first card is an A. Then it's going to check if the 2 card is in 10 card. So if it is a 10, a king, a queen, or a jack. That's what it's going to check. Then and then maybe we can make this OR, and then we switch these two around. So what we're going to do is just copy this line, paste it, change this to 2, and change the 1 to 1. So now it's going to check if card 1. If this isn't the case, then it's going to check if card 2 is an A, and card 1 is in 10 cards. I think we can leave out the if statement, and we can just go straight to a return, because then it's going to either return if this is true or if this is false. This is what we're going to check. Task 4. Yeah, that works. That works. Let's move on to task 5. Splitting pairs. Splitting pairs. If the player's first 2 cards are of the same value, if cards have same value, then split. Define the function with parameters, determine if the 2 card hands can be split into 2 pairs, then can be split, return true or false. So we need to call upon the value of card function again. Return so what we will do is return ace num card 1 is equal to ace number 2. Done. Okay, let's move to task 6. Doubling down. Task 6. When the original 2 cards dealt a total of 9, 10, or 11 points, player can place an additional bet equal to their original bet. Doubling down. Define the function, determine if the 2-card hand can be doubled down, and return a boolean true if it can and false otherwise. So we will call upon the value of card function again. So I'll just copy it and I will call this double. Then we will return card 1, that's card 2, in 9, 10, 11. Let's see if this works. Yep. Okay, so that's how you solve the Blackjack exercise on Exercism.